want your GMO!
Throughout the late 90s and well into the 2000s, the science of genetic modification was at the centre of protests and fierce debate.
2, 4, 6, 8, we don't want to mutate!
In 1996, the Hazardous Substances and New Organisms Act, HASNO for short, restricted genetic modification to research within labs.
GMOs are not needed in New Zealand.
And who could forget John Campbell's interview with then Prime Minister Helen Clark over the Corngate saga?
Prime Minister Irma estimated that 15 to 30,000 plants, corn plants, were genetically modified.
John,
is it possible that the people of New Zealand may be offended, much more offended than you are by my interview, by the fact that over the summer of 2001, they were eating genetically modified corn?
But now, nearly 3 decades later, scientific breakthroughs on genetic modification and editing have been life-saving.
And the way to visualise it is like Pac-Man. The little tiny Pac-Man are going around chomping away at the cancer cells and basically just eradicating cancer cells out of the body.
And there's been a growing push from experts to revisit the issue.
calls for change to our 16-year-old laws governing biotechnology.
Now, some of our leading scientists, politicians and the Climate Commission want us to look at opening the door to some GMO advances.
Last week, that call was answered.
Today, we are really pleased to announce that, as promised, the government will end the effective ban on gene technology in New Zealand.
So were our initial fears around the risks and impact of genetic modification unfounded?
Much of the work that we've done in terms of talking to consumers, both here and overseas, much of the hesitancy is because they don't know enough about the technology. So there's still a large number of people that don't feel confident to be able to either have an opinion or embrace the technology just because they don't know enough about it.
Kia ora, I'm Davina Zimmer, and today on The Detail, we'll look at that technology, gene modification and gene editing, and what we can expect to happen now that restrictions are easing. But first, David Downs is a business leader, public servant, consultant, board director, speaker, and, in his own words, a genetically modified organism. Here is his story.
So I had cancer. I had lymphoma, which is a blood cancer, in 2017. And I spent about a year getting the normal traditional treatment, the stuff we have available in New Zealand, which is chemotherapy. And ultimately it didn't work. I got to the point where the doctor basically said, we've run out of options. That is it, end of the line. Maybe you need to go home and make the most of the time you have left. And I was only in my mid-40s. It felt like a really, abrupt end. But I was very lucky, incredibly lucky, to get on a program, a clinical trial program in America. And it was an amazing piece of luck and coincidence almost. Someone had read about my story. He reached out to me over the internet, someone I'd never met. And through his help, I managed to get on a clinical trial in Boston. And it's a genetic modification. It's a thing called CAR T-cell therapy, where basically your T cells, which are part of everyone's immune system, are genetically altered in order to help them recognize and then fight cancer, and particularly blood cancer, the one I had. And obviously it worked, spoiler alert, I lived. But when I came back to New Zealand and realized that, I was very lucky to get on it, it certainly was incredibly expensive. It cost hundreds of thousands of dollars. Lots of people helped me, which was amazing. But I met so many patients who can't afford that, can't get their head around going to another country for cancer therapy, particularly at times when, they haven't got a lot of time available to them. And so, having the opportunity to bring these sorts of treatments to New Zealand is so critical. One of the barriers that's been in place is definitely our policies and laws around this stuff, because it just makes it way too hard for the pharmaceutical companies who have these treatments to bring them to countries like New Zealand. And even when we develop them in New Zealand, and we have been, it's been incredibly difficult for them to do that, to the point where they're having all sorts of silly rules and laws and barriers put in their way just to do the stuff that is literally saving people's lives.
David is talking about the research at the Milligan Institute. We'll come back to that later, but first, let's hear about David's experience with the gene editing technology CAR T-cell therapy.
Well, the CAR T-cell therapy is, from a patient's perspective, is very straightforward compared to the normal treatments. Chemotherapy is the normal treatment for blood cancer. That is essentially poison. You're putting poison in the human. You're trying to kill the cancer cells. The side effects from that, all sorts of tiredness and hair loss and all those sorts of things that you know about with chemotherapy. When you go to CAR T-cell therapy, it's very different because instead of trying to kill the cancer, the CAR T-cell therapy, it basically assists the immune system to do its job. And the theory here is that the immune system is really good at fighting infection. It's just cancer looks to the immune system like a normal cell, so it leaves it alone. And so CAR T-cell therapy is trying to teach the T-cell what cancer looks like. So my experience was going into get my blood taken out, which takes a few hours, but it's not particularly difficult. Then they send that blood off to a laboratory. I wait about 3 weeks while those T cells get genetically engineered, and that's very precise. Then they send it back to me, and I basically get one injection. And then essentially it takes 2 to 3 weeks for that to work. And essentially what's happening is you feel like you get the flu. For my case, it was a pretty mild flu because that's exactly the same response that you'd get when your immune system goes into action. Those T cells can now recognize the cancer cells because they've been told what cancer looks like, if you like. And the way to visualize it is like Pac-Man. The little tiny Pac-Man are going around chomping away at the cancer cells and basically just eradicating cancer cells out of the body. When I went back and got the tests 3 or 4 weeks after when I had the shot, they basically said, that's it. There's no sign of cancer left in your body.
And it cured you?
They call it in remission. That's sort of the technical term for a while. And then after a while, they go, actually, you can call yourself cured now. That's usually 5 years. So 5 years afterwards, I now call myself cured. Yeah.
Wow. And you said for you, it only took one injection. Does it take more
Correct.
for some people, depending on the severity of the cancer?
Typically not. No, it's typically one shot once. In fact, all the protocols that I know about are doing that. They'll vary the number of cells that you get based on your body weight or your gender and stuff like that. But actually, it's one shot. You can get side effects. The side effects are typically it working too well, frankly. When you put these immune cells back into the body, they can go into kind of overdrive. If there's lots of cancer in your body, lots of cancer cells, you can almost get a sort of a shock impact where your immune system suddenly goes into overdrive.
Like we mentioned, this treatment is being trialled in New Zealand.
Well, the second round of a groundbreaking clinical trial is about to get underway at Wellington Hospital. 60 patients with a rare non-Hodgkin lymphoma blood cancer will be given a cell therapy which reprograms their immune cells to recognise and kill cancer cells. They'll be treated over 2 years by the Madigan Institute, which has seen more than half of the patients in complete remission since setting up the trial 5 years ago.
The results coming out of the Madigan Institute are the best in the world. Patients are receiving a lower dose and experiencing the fewest side effects. It's also much cheaper than what David had to fork out for his venture to America.
So the Madigan Institute, again, they've been doing their clinical trial in New Zealand of their treatment. It hasn't cost the patients anything. Like it literally cost me over $300,000, $400,000 to go to the States and do my treatment there. Here in New Zealand, the patients that have been treated so far, it's been free under this clinical trial. And the change to the rules will mean that other pharmaceutical companies will now hopefully come back to New Zealand in time. It will still cost some money, but it will be a lot lower because a big part of the cost is the administration, the doctors and nurses and the blood services and all that sort of stuff. And New Zealand is relatively well set up for that stuff. We've just got to kind of line it all up properly. So I think it really is game changing. I mean, I have personally talked to probably a couple of hundred patients over the last 4 or 5 years since I came back from my treatment. And I've probably seen about 50 of them go overseas for treatment, including, some paid for by the government, our own government, but most paid for themselves personally. So you're talking about, tens of millions, if not $100 million worth of expense that shouldn't need to be, taken by individuals.
And that's where this new legislation could be life-saving. Richard Newcomb is a chief scientist at the Plant and Food Research Centre in Tamaki Makaurau. I asked him what this latest announcement will change.
Currently, the regulations are kind of a one-size-fits-all approach where we have a very high regulatory set of hurdles to get over for any kind of gene technology that falls under the definition as outlined in the HASNO Act. So where we're moving to as a country will be regulations that are more proportionate. So those technologies that are lower risk will have lower levels of regulatory compliance. while those that are perceived to be higher risk will still have the higher barrier to cross. So potentially, these new gene editing technologies that produce changes that are much more similar to those sort of changes you see in nature will have much lower regulatory hurdles to get over, and therefore we'll see more of these sort of technologies coming out of the lab and being trialled in New Zealand.
Can you give me some examples of what some of these low-risk technologies that New Zealanders actually might be seeing being used in public soon?
Sure. So the kinds of things that gene editing can be applied to include some of these CAR T-cell technologies in medicine that provide remedies or medicines for cancer or treatments for cancer patients. Those involve editing an individual's own cells and putting them back in their bodies as a form of treatment. So I think we'll see CAR T-cell therapy becoming available in New Zealand. In terms of crops and applications in agriculture, I think we'll see a range of different applications. They're not going to come out of the lab the next day, but sort of over the coming years, I think we'll see things like dealing with some of the issues in front of us, like climate change. I'm sure we'll see in the fullness of time some of the problems we have, like wilding pines, being solved by gene editing, creating pines that no longer have the ability to wild and spread like a weed. In terms of horticulture, climate resilience is a big issue for us. And at the same time, making sure the crops that we produce are resistant to pests and diseases and we don't have to use so much pesticide, but also making them more nutritious and delicious for consumers out there as well. So I think there's a range of different applications, and we'll start seeing them coming out in the next few years, once the regs change, of course.
Gene editing, gene modification, are they the same?
Sure. So I talk you through that. So the initial technology that was developed over 20 years ago now was basically we could insert genes into an organism's genome, but we couldn't predict where that insertion would be in the genome. And so there was the perceived risk that we might be interrupting other processes within that genome. Under this new technology called gene editing that's used as this CRISPR-Cas technology, we can now make precise changes, and also we can make changes that are much more like the mutations that we see out in nature as well. So under the New Zealand legislation, the definition of a GMO captures both of those technologies. But we're going to see with these new regulations will be a differentiation between the kinds of technologies where we can use these precise new gene editing technologies versus the introduction of genes using the more classical GMO technologies.
So when we're talking gene modification, that is just the more old school ways of doing things, whereas gene editing is the newer way of doing things.
Correct.
Am I correct?
That's right.
Okay.
And a lot of other countries and jurisdictions have moved to differentiating between the two technologies and then making the regulations that they use governing those technologies more proportionate, because the risk level is perceived to be much lower using gene editing technologies.
After nearly 3 decades of GMOs being essentially banned, it's understandable that response to this latest news has been mixed. A poll on RNZ's The Panel last week showed only 28% of listeners thought easing legislation was a good idea. Those against it cited concerns about the health risks and environmental impacts. But Richard says people around the world have been consuming genetically modified food for the last 2 decades, and research has found no harm was caused.
Also, under the new regulations that will come in, there will still be a need to make sure these foods are safe for humans and for the environment. So it's not as if those regulatory hurdles are going to disappear completely.
New Zealand, on the world stage, is kind of seen as this clean, green country. Do you think that introducing gene modification is kind of going to damage that global reputation that we have?
That's becoming the sort of debate point where we are now in the discussion around gene technologies. Overseas, much of this is dealt with by separating supply chains. So there will be people that will brand their products organic or however they wish to brand it, and they separate their supply chain, how the food's produced and how it gets to market and the packaging and the claims there and the branding from others. We are doing some research here to look to see whether there's any kind of clean green halo running across all of New Zealand's products, or whether that would be captured on a product by product case. So just a sort of a preview before that research comes out, well, certainly what we are seeing is that how overseas consumers view New Zealand is kind of quite different for different countries. And a key thing that's coming out of that is that actually safety. New Zealand has a really good reputation in food safety. And if this technology is associated with making foods safer, then actually they will embrace the technology in these various jurisdictions.
So let's talk safety. What are some safeguards that should be put in place to ensure that gene modification, gene editing doesn't get out of hand?
So, I mean, some of the issues around, say, gene editing is that sometimes and on very rare occasions, you actually get changes not in the place that you wanted them to occur. And certainly we can detect those by sequencing the genome of the product now. That technology is pretty straightforward. We do that routinely here. We imagine that we would sequence the genome of the product and make sure that the changes that we're targeted are only the changes that we see in the product. So we can make assurances that we've done what we think we aim to do. So it's techniques like that I think will become assurances in terms of food safety for the regulatory body that's going to be formed and look after the space.
And this regulatory body, who's going to be on that?
We don't know the details of that yet. That's all yet to be worked through. That it will be quite broad, and it will be people that will be able to assess risk in a range of different areas to the environment, to human health. But also, I think another function of the regulatory body would be to make sure that there'd been sufficient consultation with iwi groups, for instance, as well, to make sure that they had consulted reasonably widely on some of these issues. Details are not clear yet, but we imagine that we would have to apply for a license to produce and take out of the lab a certain proof of concept product. And depending on how the technology that we'd used, either gene editing or some other technology, that we would get a license to do so with various conditions attached. And again, depending on the technology, the regulatory hurdle would be set at a certain height.
And then in terms of transparency with consumers, when it comes to genetically modified products that are there for human consumption, what kind of things are looking to be done in that sphere?
So our food standards are actually regulated by a different organisation called FSANZ, and that's joint with New Zealand and Australia. And one of the reasons we're bringing our gene technology regulations in line with the Australians, or at least using the Australian regulatory approach to guide ours, is that because we have joint food standard authority, that brings us in sync across those two areas. Any issues around sort of food safety will also bring in FSANZ and their regulatory, and they're also changing their regulatory framework at the same time to bring it in line with these new changes.
I mean, New Zealand, I'm just, as a consumer walking through, Woolworths, Pack and Save, New World, Foursquare, we import quite a lot of our food anyway. So are the chances that we are already consuming genetically modified food pretty high?
So again, that's governed by FSANZ. So if the foods are genetically modified, and they make up over a certain percentage of the processed food, then that food must be labelled. So there are foods that are coming in that contain genetically modified constituents. A classic would be soybean, but that would or wouldn't be labelled depending on the proportion of that in the processed product. There are a number of approvals that have been given to import genetically modified foods. for use in New Zealand. So yes, I would say New Zealanders are consuming these, but whether they're labelled or not, as I said, depends on the proportion of it in the processed food.
So if some GMO foods are already on supermarket shelves and other forms of the technology have the ability to save hundreds of lives, what's holding people back from embracing it? Here's David again.
I think, this should always be an informed discussion and debate. I don't think it's not great to take sides or, to have it as an argument. It should be informed. I do get worried when people make uninformed comments. Some of the perceptions around genetic modification are very, very outdated, if they were ever true at all. Our legislation in New Zealand has been in place for 30 years or nearly, and it's based on a set of technologies that have now completely changed. But B, even at that time when those laws were put in place, there was a lot of obfuscation and false sort of narrative. One of the key things to realise is this is not a free-for-all. We're not opening up gene editing and suddenly our whole world will change. It'll be regulated through a very careful regulation model. Things that go into our food system or can have the ability to replicate will be treated very differently. My treatment, for example, if you took the T cells that were genetically modified from me and put them in someone else, they would immediately die. There is no possibility of them, getting into the wild or having an impact for anyone apart from me. So the debate needs to be more nuanced than just it's good or it's bad. The debate needs to be around what's the incremental benefit and what are the potential risks, and are the benefits worth the potential risks? In the case of cancer therapy, like I had, the potential risks are so minuscule as to be almost non-existent, and the potential benefits is literally hundreds of people's lives a year. So to me, that calculus is pretty simple. And I think the discussion's really got to be respectful of the people that can benefit from these things. Because, what you've got to really keep in mind is that there are real human beings whose lives will be saved because this is going to help them. And to lump that all together into this big, it's too hard, I'm too fearful, really does a disservice to those people. So you've got to be thoughtful about, where we're going with this and the impact it will have on individuals.
Washington's backbone, Einstein's eyebrows, Florence Nightingale's tenacity, though I'll have to clip around her moral fibre.
You're going to take DNA from these historical figures and add it to your own.
I shall be the wisest and strongest maniac ever to bring the blessings of dictatorship to the world.
I don't foresee a day where, we will kind of hack our genomes and, I want blue eyes, so therefore I'm going to go and do that. That's not what we're talking about. And again, some of the debate gets very trivialized. What we're talking about is really advanced science where the science will tell us that these changes are, suitable and make a difference to people, gone through appropriate checks and balances and appropriate regulation and things like that. But instead of banning it outright, we're now giving ourselves the opportunity to use some of the latest tools. The change in technology has been so dramatic. It's as if we were all still driving around in 1970s cars that broke down all the time, and we didn't use any of the airbags and the ABS braking and all of the kind of advanced technology that now helps us. We just stuck with the old thing because we were scared of some of these new inventions. The reality is technology has moved incredibly far. We now know so much more than we did 30 years ago, and it has a really direct benefit for us.
That's all for today. The Detail is a newsroom production supported by RNZ and NZ On Air. This episode is engineered by Rangi Powick and produced by Gwen McClure. Thank you to David Downs and Richard Newcomb. I'm Davina Zimmer, ka kite anō.